Have you ever wondered what it would actually feel like to fall into a black hole? Not the science textbook version, but the real experience. What you would see, what you would feel, and what would happen to your body second by second as gravity becomes stronger than anything you've ever imagined. Today we're going to take a journey to one of the most extreme places in the universe and explore what you'd experience inside a black hole. Before we start, make sure to like the video, subscribe to the channel, and turn on the notification bell so you don't miss future space videos. And if you enjoy this kind of content, let me know what topics you want to see next by leaving your video ideas in the comments. To understand what it's like inside a black hole, we first have to start far away from it. Imagine you're in a spaceship traveling through deep space, heading toward a massive black hole. Maybe it sits at the center of a distant galaxy, millions or even billions of times more massive than our sun. From far away, it doesn't look like a giant cosmic vacuum cleaner. In fact, it might be almost invisible. What you would notice first is the strange behavior of light around it. As your spaceship approaches, stars behind the black hole begin to stretch and bend into arcs. This happens because the black hole's gravity warps space and time itself. Light traveling past a black hole is forced to curve around it, creating a distorted halo known as gravitational lensing. The universe would start to look like it's wrapped around a sphere in front of you. If the black hole is actively feeding on nearby matter, you might also see an enormous glowing disk swirling around it. This is called an accretion disk, made of gas, dust, and debris spiraling inward at incredible speeds. The friction in this disk heats the material to millions of degrees, causing it to shine brighter than entire galaxies. If you got too close to that disk, the radiation alone would destroy your ship instantly. But for the sake of this journey, let's imagine we approach the black hole from a safe direction where the disk isn't in our path. As you get closer, something strange happens to time. According to Einstein's theory of general relativity, gravity affects the flow of time. The stronger the gravity, the slower time moves compared to the rest of the universe. Near a black hole, this effect becomes extreme. If someone far away were watching your spaceship with a powerful telescope, they would see your approach slow down more and more. To them, it would look like your ship is moving in slow motion. As you get closer to the edge of the black hole, your signals would become stretched and redder, fading away until you appear frozen at the boundary. That boundary is called the event horizon. It's often described as the point of no return. Once anything crosses the event horizon, not even light can escape the black hole's gravity. From the outside, it's the last place the universe can still see you. But here's the strange part. From your own perspective, inside the spaceship, nothing dramatic happens at the exact moment you cross the event horizon. There is no wall, no sudden flash, and no sign saying you've entered a black hole. If the black hole is large enough, you might not even notice you've crossed it at all. Instead, the universe outside would start behaving in very strange ways. Because of the intense distortion of space-time, light from every direction begins bending toward you. The entire sky could appear to shrink into a bright, warped circle above you, while darkness surrounds everything else. Meanwhile, gravity is becoming stronger and stronger the deeper you fall. At first, you might only feel a slight pull, similar to the gravity of a planet. But as you continue falling inward, the difference in gravity between your head and your feet begins to grow. Your feet are closer to the black hole than your head, which means they feel a stronger gravitational pull. This difference is called a tidal force. Inside a black hole, tidal forces can become unbelievably powerful. Eventually, the pull on your feet would be so much stronger than the pull on your head that your body would begin stretching. Scientists sometimes refer to this process with a surprisingly silly name, spaghettification. It describes exactly what it sounds like. You would be stretched longer and thinner, like a piece of spaghetti being pulled apart. At the same time, gravity would compress you from the sides, squeezing your body inward while pulling you outward. The result would be a long, thin stream of matter falling toward the center of the black hole. But the exact timing of this depends heavily on the size of the black hole. If you fell into a small, stellar black hole, maybe only a few times the mass of our sun, the tidal forces near the event horizon would already be incredibly strong. You would be stretched apart even before crossing the boundary. However, if the black hole were supermassive, like the one at the center of the Milky Way, the event horizon would be enormous. In that case, The tidal forces at the boundary might actually be mild enough for you to cross it without immediate destruction. That means, in theory, you could fall inside a supermassive black hole and survive for a short time before the real chaos begins. As you continue falling deeper, time itself becomes more distorted. Outside the black hole, the rest of the universe continues evolving. Stars form, galaxies collide, and billions of years could pass. But for you, the journey inward might only take minutes. If you looked outward during the fall, the universe might appear to speed up dramatically. Light from distant stars would become increasingly blue-shifted and energetic. You could watch the future of the cosmos unfolding above you in fast forward. Galaxies could evolve in moments. Stars could explode and fade away. The night sky might transform into a chaotic display of accelerated cosmic history. But eventually, even that view would disappear as space-time curves more severely around you. All paths inside the event horizon lead deeper inward. In normal space, you can move in any direction you choose. Inside a black hole, moving toward the center becomes as unavoidable as moving toward the future. No amount of rocket power can stop the fall. The center of the black hole is called the singularity. According to our current understanding of physics, the singularity is a point where density becomes infinite and the laws of physics break down. Gravity becomes infinitely strong, and space-time curves infinitely. But the truth is, we don't actually know what really happens there. Our best theories, including general relativity, cannot fully describe the singularity. To understand it properly, we would likely need a complete theory of quantum gravity, something scientists are still trying to develop. So the final moments of the journey remain one of the greatest mysteries in modern physics. What we do know is that the tidal forces would continue increasing as you approach the center. Your body, your spaceship, and every atom within you would be stretched and torn apart. Eventually, even molecules and atoms could be ripped into their fundamental particles. Everything that once made you would become part of the black hole. But even this raises strange questions. Some physicists wonder whether information can truly disappear inside a black hole. According to the laws of quantum mechanics, information about physical systems should never be completely destroyed. This leads to the famous black hole information paradox. If black holes erase information, it would contradict one of the most fundamental principles of quantum physics. One possible answer involves something called Hawking radiation. In the 1970s, physicist Stephen Hawking discovered that black holes aren't entirely black. They slowly emit radiation due to quantum effects near the event horizon. Over incredibly long periods of time, this radiation could cause black holes to shrink and eventually evaporate. For a small black hole, this process might take billions of years. For a supermassive black hole, it could take longer than the current age of the universe multiplied trillions of times. If black holes eventually evaporate, the question becomes, where does all the information about everything that fell inside go? Scientists are still debating possible solutions, including the idea that information might be stored on the event horizon itself or encoded within the outgoing radiation. Another strange possibility proposed by some theories is that black holes might connect to other regions of space-time. These hypothetical tunnels are known as wormholes. In science fiction, wormholes are often used as shortcuts for traveling across the universe. But whether real black holes could actually form stable wormholes is still uncertain. Most current evidence suggests that if wormholes exist, they would likely collapse too quickly for anything to pass through safely. So unfortunately, falling into a black hole probably wouldn't transport you to another galaxy or another universe. The more likely outcome is that you would simply be crushed and stretched beyond recognition as you approach the singularity. Even though this journey sounds terrifying, black holes are also some of the most fascinating objects in the universe. They shape the evolution of galaxies, power enormous jets of energy, and challenge our understanding of the fundamental laws of physics. In fact, in 2019, humanity captured the first ever image of a black hole's shadow. It showed the glowing ring of hot gas surrounding a dark center, confirming predictions made by Einstein more than a century earlier. And scientists continue studying black holes today using powerful telescopes, gravitational wave detectors, and advanced simulations. Each new discovery brings us closer to understanding what really happens in these cosmic abysses. So, while we may never safely experience falling into a black hole ourselves, exploring the idea helps scientists test the limits of physics and uncover the secrets of the universe. And who knows, maybe one day future theories will reveal that the inside of a black hole is even stranger than we can currently imagine. Before you go, make sure to like the video, subscribe to the channel, and turn on the notification bell so you never miss our next exploration of the universe. And I'd love to hear your thoughts. What part of falling into a black hole surprised you the most? Let me know in the comments, and if you have ideas for future videos, drop them down there as well. Your suggestions might inspire the next adventure into the mysteries of space.